Now, as for the rule about subtraction, let's say, for example, you have y is equals to ub. It follows the same as the rule for addition. Because if you have for a function of b itself had a negative sign, and therefore the derivative would also be negative. So if you are going to differentiate y is equals to u minus v, then we will have ddx of y, ddx of y, or dy dx is equals to the ddx of u minus the ddx of v. So that is our formula if you are going to use the rule for subtraction. Okay. However, if we are going to proceed with the rule for products, this is not quite simple. Let's say, for example, we are given the same example. Let's say we are given y is equals to x squared plus c multiplied by ax to the fourth plus b. Then we are now going to determine the value of dy dx. So certainly, we cannot make use of the same ruling for addition and for subtraction. There are two ways in which we may go to work considering this kind of equation, linear equation. The first way is that you multiply first, then you can differentiate. So accordingly, we can multiply together x squared plus c and ax to the fourth plus b. So if you are going to multiply ax squared plus c with ax to the fourth plus b, okay, so this will be our first way. So the first way could be multiplying x squared plus c and ax to the fourth plus b. Then we would have x squared times ax to the fourth will be ax to the sixth plus you have ax to the fourth times c. This is c x to the fourth plus, of course, you're going to multiply b times x squared. So that would be plus b x squared. And if you're going to multiply b times c, that would be plus b times c. And then we can now differentiate. So once we differentiate here, that is ddx of y, differential of ax, the derivative of ax to the sixth is equals to 6 ax to the fifth power plus the differential of ax to the fourth is simply equals to 4 times a times c, then x raised to the third power plus the derivative of bx squared, that would be 2 times b times x. And then of course you have b and c, b times c is a constant, so the derivative of the constant is equals to 0. So this is our first way. The second way could be, the second way would be, we go back to the first principle and then we consider the equation y is equals to u times v. Y is equals to u times v. Wherein u, in this case, is x squared plus c, and b is ax to the fourth plus b. So in this case, we are going to the same procedure for the rule of addition. You're going to add y, increase the value for y, so that would be y plus dy. That is equals to u plus we are going to add du. Then multiply it by v plus we are going to increase it, so that would be plus dv. So we will have u plus v plus u times v, u times v, u times v plus dv times u times dv, u times v plus u times dv, u times dv plus v times du, v times du plus du times dv, du times dv, du times dv. So now you would notice, remember that in this first equation, y plus dy, u is one function of x and v is another function of x. Then we grow y, that would be y plus dy, and we grow x, that would be x plus dx. And then that means u will become u plus du, and v will become v plus dv. And then by using the principle for multiplication, u times v, that is u times v, plus v times du, v times du. And then you have u times dv plus v times du and plus du times dv. So we shall have now du and dv, which is a small quantity of the second order of smallness. And therefore, in this particular limit, it can be disregarded. So once we disregarded the value of du and dv, disregarding the value of du and dv, then we will have y plus dy is equals to u times v plus u times dv plus v times du. So afterwards, we can subtract. What do we subtract? We subtract the original u times v, just as the same procedure that we use for addition. But this time, we are going to use multiplication. That is for the product. So if we are going to subtract the original y is equals to u times v, we are going to eliminate u times v because we are going to subtract the original value of u times v here. Then what is left to us will be dy we eliminate y is equals to u times v. So y is equals to u times v. That gives us the value for dy, which is u times dv plus v times du. And then if you are going to divide both sides of the equation with dx, then that would give us d dx of y is equals to u times d dx of v plus v times d dx of u. And that would give us the value for dy over dx, which is equals to, if you are going to use this equation, the second way to differentiate the product of two functions, you multiply each function by the derivative of the other, and together the two products are obtained. So that would mean if you are going to let u is x squared plus c, if we are going to let u is equals to x squared plus c, while v is equals to ax squared plus b, according to our example, then we can make use of this formula for the process for determining the derivative of the product. And therefore, that would also give us the value, okay? So dy dx, the differential. So let us say we are going to use this formula. Okay? Dy over dx is equals to u times dv over dx plus v times du over dx. So from our example, we let x squared plus c is equals to u, and ax to the fourth, this should be ax to the fourth plus b is equals to v. Then we are going to apply the general rule that we have established a while ago. So using dy dx, that would be equal to u. We let u to be x squared plus c. So we have x squared plus c. And then you multiply it with the derivative of u. So that is d dx of ax to the fourth plus b. Plus, we are going to determine v is ax to the fourth plus b, ax to the fourth plus b, and then you multiply it by d dx of u. So d dx of x squared plus c. So we have now dy over dx x squared plus c, and then determine the derivative of ax to the fourth, so that is 4ax raised to the third power, and then d dx of the constant is 0, plus, we have plus ax to the fourth plus b, then multiply it by the derivative of x squared, which is 2x. Derivative of c, or the constant, is equals to 0. So this would mean that we can have dy over dx is equals to 4ax cubed times x squared is 4ax to the 5th power plus 4ax cubed times c is simply 4acx cubed plus, of course, you have ax to the 4th times 2x. So that would be 2ax raised to the 5th power plus 2x times b is equals to 2 times bx. So again, if we are going to continue with the determination of dy over dx, that is simply equals to 4ax to the 5th plus 2ax to the 5th power. So that is 6ax to the 5th power plus, of course, you have 4acx cubed plus you have 2bx, which is basically the same answer that we got from the first way.